All right, I told you guys I would be back, and here we are. We are back. So, we are going to be continuing our journey through the land of Neetcode. And so, in my last video, about maybe an hour ago, we did some problems. We did encounter some issues. So, I want to go back to those problems that I was encountering some issues on, try to understand them a little bit more, and then do some new problems as well, continuing our journey through this process or this domain, this map of Neetcode. Okay, so let's make myself a little bit smaller. And there we go. Let me also brighten my screen. Okay, so we just got this one, which this one was a backtracking problem. We were able to get that one. One that we were having some difficulty in was, and I put a star on it. Where'd it go? This one. Okay, so binary tree level order traversal. All right, so I was trying to do it with a stack, and then when I looked at the answers in the last video, they were doing it with a queue. So one of the questions that I want to ask is, okay, well, what is when would you use a queue and when would you use a stack? Like, what is the effect? Obviously, I know a stack, you add to it and then you pop from it, and then a queue is more like a line. But my question is, like, when would you use one versus the other, and how would I actually think about when I would use one versus the other? So I'm actually just going to delete this, and then I am going to say Q is equal to, is it like this, I think? And then we have, I believe, q dot append and q dot pop. I think those are our two. Was it pop left, actually? Right? Because you're popping from the left, so you're popping the first one. Yeah, I think that makes sense. Okay. So now what I want to do is, remember in this problem, what we want to do is add each level of this tree. So I want to add this node 1 to my answer, okay? And I want it to be by itself because it's the only node on that level. Then I want to add 2 and 3 right here because they are the only ones on their level. Okay, and likewise 4, 5, 6, and 7 are all on the same level, and they all go in the same category right there. Okay, so the way that I'm thinking about it is I need some way to keep track at the beginning when I enter my while loop. So I still want to do something which is like while q. So while I still have nodes, and I want to iteratively traverse this. Okay, so while q, now well, first I actually do need to add q dot append and then root, okay? And then, so if this is null, this is, let me just make sure, like, if not root, return, what do we want to return? Just an empty list, right? Yeah. So now, okay, so I have Q, and I want to keep track of how many elements are in the queue as of right now. And the reason that I want to do that is because we have one element in here, and I only want to process this one element. Then in the next iteration of the while loop, I want to process 2 elements. Then in the next one, I want to process 4. So what I'm going to do is I'm first going to get the information of how many elements are in my queue. So num in queue is equal to the length of queue. All right? So right now it's going to be 1. Now what I want to do is I want to say for I might even be able to do this, for blank in range num in Q. And then how do I want to deal with this? I now want to add this one's children node to my queue. So I want to do queue dot append first I want to get the node. So node is going to be equal to queue dot pop left. Okay, and now I'm seeing why I would use a queue instead of a stack, because I don't want to process the node that I just processed. I want to process them in the order that I've seen them. So it actually makes sense now. Okay, yeah, it makes sense. Okay, so then append, and I append to the end. Okay, what do I want to append here? Node dot left, and I also want to append queue dot append node dot right. Okay, and during this I do want to add each node to my answer. So I'm going to come here, and each time I am going to do like current level is equal to an empty list, and then I do current level dot append here and I want to append the node. Now, does it want the node or the value? Return a level order traversal contains the values of each node. So I want dot val right there. And then at the end of this, I want to take that current level and append it to my answer. So answer dot append current level, right? And then we come back up here, and for the next layer, we create a new level. Okay? So now I will answer is equal to a blank list, and now I can actually just change this to answer, and then answer. I might not even need this, but I don't know how appending null, I'm not sure how that would play. Let's run it. Okay. Node dot left has no attribute node dot left. Oh, right, because okay, so that's what happens when you append null. So I'm kind of used to the backtracking and recursion kind of things where we can pass in a null value and then it gets processed in the previous one, or the next recursion call, and you just do the if not node protection. So, well, in this case, what I need to do is I'm guaranteed that I do have a node. Okay, so I want to say if node dot left, then we do this. If node dot right, then we do this one. Okay, let's see. Well, we still got an Okay, well that's not what I'm hoping. Oh. There we go. Good. Awesome, awesome, awesome. Okay. Nice, 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 nice. So we're gonna come back up to here, and I don't know. We've been playing around with a whole bunch of areas. Where do we want to go from here? Should we do a dynamic programming problem? Okay, fine. A climbing stairs, easy. I don't know about how easy it's gonna be. Okay, how easy can a dynamic programming problem be? We'll find out, I guess. Okay, so you are given an integer n representing the number of steps to reach the top of the staircase. You can climb with either 1 or 2 steps at a time. Return the number of distinct ways to climb to the top of the staircase. Okay, so I know that I've seen this problem a long time ago. And I know that I'm supposed to start at the back. I remember that. Not remembering much else. So, dynamic programming, we need like an array which will keep track of something, and my job is to kind of fill this array out as I go, and then try to see if some kind of like anyways, some kind of insect or something. So I need to create an array which will tell me some information, and then I need to fill that information out, and then I need to use that information to do my process. Something like that. So we want something like steps is equal to maybe like a array like this multiplied by n, the number of steps to reach the top of a staircase. You are given an integer n, representing the number of steps to reach the top of the staircase. Okay, so this is number of like actual steps, not physical steps. Okay. And we want to find how many distinct ways to climb it. Oh, so we're not even trying to find like what is the minimum way. Okay. So at the end, how many ways, if I'm at the last step, how many distinct ways are there to get to that step? Well, there's 0. Maybe I say that there's 1, which is where I am at. Okay, so let me see, at 0, that is 1. Okay, and then at step 1, there's also 1 way, which is I'm at my current step, and I take 1 step forward, and I reach the second one. Now, if I'm at step 2, then I can either take I can either take 2 steps, okay, bing bing, to get to the top, Or I can take one step and then one step. And now that I'm saying this out loud, there is a dependency on the previous answer. So I can either take this one, just jump to this one, or jump to this one. And how many distinct ways is there here? There's one. How many distinct ways is there here? That's also one. So I am, let's see, this is my step of like 2 plus step of 1. Kind of like that, like index here. Okay, and then I want to say for step 3, I can either take one step here, and then I've already calculated how many more possibilities I can have if I take this step, or I can take this step, and my path is kind of forced because I just can only take one more. So this one is going to be step of 3 right here, so this one, plus step of 2, meaning this one. Okay, so now how do we do this? So for I in range n, okay, and I just want to add the first ones. So steps indexed at -1 is equal to 1. Steps of -2 is going to be equal to 1. It's going to be equal to 1. And then from that, I should be able to build out the rest. So I want to start actually at 2, right? It's going to be the last one. This one is going to be there. Am I going to get it off by 1 error? Possibly. So maybe I want to say I want to start at n minus 1 or -2, and I want to go to 0, but I want to include 0. So then I can do steps indexed at I is going to equal steps indexed at I plus 1 plus steps of I plus 2. Now we are guaranteed, as long as these ones exist, we're guaranteed that these are in existence. So let me actually fix this right here. If length of steps is less than 2, return 1. So there's one distinct way. Now, if there is 2 steps, I do 1 and 1, and then for I in range. Now this is going to be, in is the number of steps, okay? So this is going to be 2. Might even be able just to do in right there. So this is going to be 2 minus 2. Okay, so it's 0, and we do want to run it on the 0th index, right? And then also, do I need to do like decreasing, something like this? Let's see. Like that? Is that the notation to the end? I think this is the notation. Okay, so then I am going to do if n is equal to 2, then we return 2, like this. Otherwise, we'll have 3 and we can work with this. So then I think we can return steps indexed at 0. So let me kind of walk through some test cases and see if this passes. So up here, if it's 0, we return 1. If it's 1, we return 1. If it's 2, we return 2. Okay. If it's 3, we will come in here and we have this one is 1. Actually, I think we're flipped, but okay, whatever. This one is 1. This one is also 1. And then I come here and I say I'm going to update you. Or do I want to update this one though, right? So 0, 1, and 2. So what am I doing? I want to be accessing this one, which is the one at index 2. So I want to start if n is 1, 2, 3, 4. So if n is 4, so I'm going to start at index 2, which is actually 0, 1, 2, right there. Okay. So I am starting here, and then I add these two up. Okay, yeah, that makes sense. And then I come back up to here, and I get the next one, and I add those ones up. So I think it should work. Is it like this? What's the syntax? Is it semicolons? I don't know. Okay, that's... What is the syntax? Okay, so I kind of had it right the first time, I think. I had something similar to this. Well, that's unfortunate. Oh, wait, hold on. I thought I was onto something. Okay, fine. line short circuits the function for all. Oh, did I just make a really dumb mistake here? Okay, well, that's it. And it should have guaranteed that it was in there. So obviously there was some kind of, there's a gap in my conception, or this. What I thought to be reality is obviously there's some misconception that I have, so I need to try to figure out why and how that is the case. So we want to go to 3. And now they're just starting at the beginning. What if I want to do it my way and have it go from the back? In +1. All of those are the same except up here, these ones. Now let's see about how they did it up here. They also did the +1. Okay, so obviously there is it's those off by 1 errors again. But if I have one step, I can have that as the 0th index, right? When I have one step, that's the 0th index. That's going to correspond to this one right here. It's not going to correspond to n. Oh wait, -1 is n, right? And then they're doing n-1. Let me just try changing this to be +1 and see if it runs. Okay, so yeah, these two are correct because that's the same thing as here. This was our problem right there. And one of the questions that I'm having is, why is it n+1? I actually don't understand that quite, why we need to do it this way. Because conceptually what I'm thinking is, if I have one element, n is going to be 1. and we are going to place that at index of 0, right? So I'm going to have 1, and I'm just going to have this thing right here, just a single element, which is 0. That's kind of what I want. I don't want 1 plus 1 is 2, so that I have 2 elements. Now maybe it just gets caught here, but that doesn't feel right. So let's say that we have 3 elements, okay? So kind of like this case. 1, 2, 3. This is going to be 4, so we're actually going to have 4 elements. The 0th is going to be here, the 1th is going to be here, and that's those right there. Okay, then I'm going to come here and find this one. Okay, so I do need to find this one, and that's going to be a step here. And this is going to evaluate to 2. I don't understand why I need to add that +1. Okay, I'm just gonna save it like that, and I'll probably come back to it later. Oh, I didn't even finish it? Okay, I'll just start it, whatever. Graphs, greedy, tries. I mean, I don't even know what a try is, but this one. You have to, the class implementation ones, okay. A prefix tree, also known as a trie, okay, so that's what a trie is a tree data structure used to efficiently store and retrieve keys in a set of strings. Some applications of this data structure include autocomplete and spell checker systems. Initializes the prefix tree object. What? Okay, no. I'll just watch a video later on that. I don't know. Should we do word search? Sure. Just looking at it, it's gonna be backtracking. All right, given a 2D grid of characters board and a string word, return true if the word is present in grid, otherwise return false. So for the word to be present, it must be possible to form it with a path in the board with horizontally and vertically neighboring cells. The same cell may not be used more than once in a word. I feel like this is very similar to the one that we just solved. I'm going to iterate through each of these. Bing, 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 until I find the first word in, the first letter in here. Bing, bing, bing. No, and then what I need to do is I need to go into backtracking and see if I can find the second letter. So something like this. So def backtrack I and J. Okay. Now base case is if I is less than 0 or I is if I is less than 0 or if it is greater than length of board. So if we're out of bounds, we just return false. Also, if J is less than 0 or J is greater than length of board indexed at 0, likewise we return false. Okay. I also want to go and have the word index. So now, if word index is equal to the length of word. Would this be word minus 1? Possibly, I don't know. We need to figure that out later. In this case, I want to check if word indexed at word index is equal to board at I J. If this is the case, we return true. Otherwise, return false. Okay. Now I want to say if does not equal board here, return false. Okay. So now I want to backtrack on the result. So R1 is going to equal backtrack, and it is going to be, I'm going to try to go up, so I'm going to go I plus 1, same J, and word index is going to be plus 1. So now we're going to just do this 4 times. 2, 3, 4. 2, 3, 4. And now this one is going to be like this. This one is going to be like that. This one is going to be plus 1. This one is going to be minus 1. And all of those are going to be like that. So now, if R1 or R2 or R3 or R4 return true, else return false, okay? And now for I in range, length, board, for J in range, length, board at 0, like this. Backtrack on I, J, and we want word index to be 0, okay? Like that, and then result is equal to here. If result return true, okay, if this breaks out, we return false. Now, the other thing is each time we're not allowed to see the same letter. So I need to keep track of that. So I need to say, each time I come here, I need to do a scene is equal to set, like this. Okay, and then in here I need non-local scene. Okay. So I want to do if the tuple I, J is in scene, then we return false, okay? And I need to actually add that. What would this be? Word index. This is going to be how many letters there are, but I do want this minus 1, I think. Okay. So in this case, I want scene.add. And I want to add my tuple of I and J. And then next time we're going to come and get a new scene. Ooh, I don't know. What do you think? Hey, accepted. Well, it shouldn't have, because it should have protected here. Oh, do I need to say like if not board return false? Is that the problem? No, okay. Well, if we're equal to 0, that's fine. If it is greater than the length of the board minus 1. Yeah, okay. Wait, no. If it's equal to the length of the board at... Oh, or equal to. I see. Or equal to the length of the board, then we do that. Nope. Okay. Right, because we can come here, for example, we can come and check this A, and then we can check this A again if we decide not to use it. So this is like deciding not to use it. Okay, whatever. And there we go. Okay, there we are. Okay, so just remember to think about when I add and subtract things from backtracking. Okay. I don't want to do a linked list, but let's do a linked list. Okay, fine. You were given the head of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted linked list and return the head of the new sorted. Okay, so we have 1, 1, 2, 3, 4, and 5. So we're just, what I think I'm going to do is I'm going to have a pointer here and a pointer here, and then I'm going to see which one is bigger. And then I'm going to add the bigger one to my new list. And then I am going to move over by 1. Yeah. Okay, so while L1 or L2, okay, let's define that. L1 is equal to list 1. L2 is equal to list 2. when either of those pointers are active, and then do head is equal to what should head be? Because I'm not creating a new node. I don't know. In this case, both of them exist. Is smaller than L2 dot val. Then what do? I want to add this to my new list. Now, do I need a new list, or can I just use like list number 1? Alright, I'm just gonna look at the solution and then go to sleep. If list of 1 is none, return list of 2. List of 2 is none, return list of 1. Okay. If list1.val is greater than or equal to list.2.val, we merge the two lists. We'll move over by 1. Okay. So this one we didn't create a new list. Iteration, create this dummy node. Okay, that's kind of what I was stumbling here. Sure, we create a dummy node. Well, list 1 and list 2, okay, that's kind of what I had, but I created this new thing. Now, I say, or he says, the next is equal to list 1. So then he's adding to that new list. And then moving over list 1's pointer by 1. Okay. And then, if either one of these are not true, you can just add the entire list. To the current list that you have. Okay. All right, well, I am going to possibly watch some videos on the ones that I starred. Let me start this one as well. So, oh, which one is it? Okay, so I'm gonna go and watch some videos on the ones that I starred, and then I'm gonna go to sleep, and yeah. So, anyways, thank you guys for watching this video. If you liked it, subscribe, and yeah, hope everything is going good. I will see you guys later. My name is Timothy Lee Grant. Goodbye.